Hello, I'm Frank Conkling, and this is Panda Consulting's ArcGIS workshop. And today, what we're going to do is we're going to look at advanced curve construction. We're going to dig really deep into all the tools that are inside of ArcGIS Pro for creating curves and look at some of the ways that those different ways to create curves can help you to solve difficult legal descriptions, both with elements that are left off, elements that are you're unsure about, and we're even going to explore maybe a little bit of spirals at the end here. At the end, we're also going to go and talk about taking care of tessellated or densified curves and how to correct them. Before we start, let me go and point out again the QR code in the lower right corner, take you to our website, show you who we are, what we do. We are Esri Business Partners, and we are the first business partner to receive the Parcel Management Specialty designation for parcel fabrics. Please go ahead and visit us. Also, if you're here live, just to remind you, Chris is actually going and moderating the chat window. So if you have any questions, any comments, anything you want me to address, please put it over there in the chat window. All right, let's get started. So what we're going to do today is we're going to look at just sort of simple curve geometry. Just how do you make up a curve? We're going to look at some of the different combinations of curves and how they sometimes can cause problems for people. We're going to look at also missing elements in legal descriptions and how you can solve for those. Believe it or not, it might not always be obvious for people, but you can solve for all of these inside of ArcGIS Pro. They've got as many tools as you used to have in MAP. They just don't call them that anymore. Then again, we're going to look at spiral curves and then correcting tessellated or densified curves. Got a lot to talk about. Hopefully you stick with us the whole time, but if not, it's always up on YouTube, and it'll all be marked as far as when we're going to address all of these. All right. By the way, just sort of as an aside, I used to teach surveying and mapping at our local college, and curves themselves, they consisted of two 4-hour sessions in the curriculum because there is so much involved in curves, and we would explore the sort of the trigonometric functions and their references and relationships to one another. We're not going to go that deep. We're just going to go sort of up on the surface, superficially. What elements do we have inside of a curve? We can start by looking at sort of we have the PC, which is the beginning of the curve. We have the PC, or the point of terminus of the curve, on there. We have radius distances. Those radius distances are the same on both sides of the curve. And we have a radius point. That radius point goes and is the point from which all the curve is actually constructed. All right, if we go and draw a line from the PC to the PT, that is called the chord distance, and the chord bearing, also sometimes called the long chord. Long chord, if you do it from the beginning to the end. There's shorter chords if you're setting up and doing instrumentation along those other ones inside. At the beginning of the curve and the ending of the curve, we have two reference lines. They may or may not come out that way. These are tangent lines. Tangent means that it is 90 degrees to where it intersects the radial lines. All right, this is 90 degrees here. This is a right angle, or 90 degrees here. These are tangent lines coming in. If you extend them out, extend that tangent out and extend that tangent out, that point at which it intersects is commonly called the point of intersection. Now, if you look at this, especially when you look at the fact that this is a right angle here and a right angle here, there's some interesting relationships that occur. For example, the angle that's subtended from the two radial lines is commonly called the central angle. Well, because this is a right angles here, that equals to this angle here up at the top at this intersection. If you were to be creating them, you would be able to do that. What that also means is that because this is another triangle here, and this is 90 degrees here, that means that this is actually equal to half the central angle here. This is half of the central angle here. So that again, there's this trigonometric relationship that occurs, and you can reconstruct almost anything using just these simple trig functions. Again, we're not going to talk about them. We're going to talk just to make sure that we know what these parts are of the individual curve on there. So as long as we recognize this, there are elements that are very, very critical to be able to go and understand what a curve is and how we can recreate it. Um, Important ones, the radius distance, the central angle, and then we start looking at some of these others which are not quite as important, but they're useful. The arc length, the distance along the curve, the chord length, the distance along the chord from this beginning to the end, and we build almost everything else from that. All right, those are sort of the critical ones. When you're constructing something inside of ArcGIS Pro, it's critical that you not just understand the curve, but that you understand what the orientation of the curve is. So believe it or not, these three curves are exactly the same curve. The only difference is that it is rotated or oriented differently as far as it relates to the lines coming into it, lines going out, so that in order to go and map a curve, you need to understand what is the orientation. Is it tangent to the previous line coming in? Or do you have a separate chord bearing? That chord bearing is not quite as critical if it's a curve which starts 90 degrees to the line coming into it. But oftentimes you'll have surveyors and people writing legal descriptions still provide the chord bearing just as a secondary check against it. Also, radial bearing. The radial bearing is, in fact, the bearing of the line coming from the beginning of the curve in. Interesting, you'll often find where that radial bearing is also defined going outward from the curve. It's not as common, but it does occur every once in a while. And then sometimes the tangent bearing is also provided. If nothing is provided as far as your orientation, it is assumed to be tangent to your previous line coming in. Just an assumption that doesn't always mean it's correct, but that's just sort of common way that we tend to refer to things. This is something I like to talk about, and that because of the trigonometric functions and the way they work, that which of these elements are more important than others? Or the question I always get is that which one of these should I put in? I've got multiples in there. I've got a radius, I've got a radial distance, I've got a central angle, I've got a chord distance, and I've got an arc length. Which should I put in? And I want to make sure that you understand that two elements here. One, with all the information that you're always given, you are always looking at the impact of rounding because every distance that you're provided has a rounding error associated with it. So whether it be the distance that's provided for your radius, it's usually given to hundredths of a foot, but it's usually measured further than that, than out than that. Same way with the arc length, same way with the chord length. They are rounded on there. The central angle is usually given to the closest second of arc, degrees, minutes, seconds, closest second of arc. Well, depending upon the length of the radius, which of these or which of these rounding errors can have a large impact on it. So if in fact, and look at it this way, if in fact we have a very long curve with a very long radius on it, and if we have one little difference here in a second of arc, the second of the central angle, that means that 1 second is going to push these distances further apart from the point of commencement or point of curve to the curve termination. That's going to make it further apart. So a rounding error in the central angle is going to give you more problems out at the arc and chord length. So that my rule of thumb is that on curves that have a long radius on them, and I tend to use 1,000 feet and above, make sure that you always put the radius distance in. And then you can use either the chord or the arc length and not the central angle, because a rounding error on the arc length or on the chord is going to have less impact on the overall calculated central angle on here than it will on a shorter radius. On the shorter radius curves, I always recommend that you use the radius and the central angle. Again, because it's a smaller radius, a central angle error in the rounding is not going to impact as much on the arc lengths and the chord lengths on there. Rule of thumb, but doesn't mean that's always what you should do, but it's something that I just looked at a long time ago, and I often will get people who are in our training classes say, why is it that when I'm inputting this information that I have, when I come out, the grid, the traverse grid, gives me a different bearing than the one that it should have on here. And it's usually because of using a radius and an arc length, which is rounded, instead of using the central angle. Another way of thinking of this is that if you're mapping inside of a subdivision, always radius and central angle. If you're mapping a road, which has a very long radius on here, radius and one of the others, the chord distance or the arc length on there. It gives you better results on what you're doing. Again, just my rule of thumb on there. All right. So let's look at now curves and how they can be put together, because this is sort of one of those things that gets people trying to figure out, well, how am I going to do this? We have a simple curve. A simple curve just has one curve. It's not connected to another curve. It has a line coming in, a line coming out. That's it. Then you have compound curves. Compound curves, you'll have a line coming in, and then you'll have one curve and then another curve right after it of a different radius. Now, that compound curve means that you actually have to input this one correctly and then input this one. But the secret to compound curves is that these two curves are tangent to one another. All right, they are tangent to one another on there. On broke back curves, where you've got a line coming in, you've got a curve, you have a line coming out for a certain distance, and then another curve. All right, these are often, unless they're specifically called out, this will also be tangent. Now, again, you want to watch the legal description and what it says on the Platter survey. Sometimes broke back curves are not tangent, so you want to pay attention to what's listed on there, what's shown on the survey. Reverse curves. Reverse curve, a line coming in, a curve, and then you've got a radius on the other side of the curve. So it's no longer, in this case, concave to the south, but it's concave to the north on here. Or to put it in Esri's terminology, this is radius to the right, this is radius to the left. Speaking of that, when you're in the traverse, radius to the right is a positive radius, a radius to the left is a negative radius. All right. This is the one that tends to give everybody a bunch of problems. This is a cusp of a curve. A cusp of a curve is where you have two curves, one against the other one, but they're not related in the normal way they are. It comes to a point and then goes off. You've got another curve that's related, that's next to it, but it doesn't necessarily mean it's tangent. The odds are it's not going to be tangent. It's going to be something else on there. So you've got two curves. They connect to one another, but they have different tangencies on them. That's one tangency that way. There's another tangency this way. And in fact, this is the point of cusp. All right, the cusp of the curve. All right. Again, these, for the most part, it's just a matter of constructing one and then going and looking and see what the relationship before that second one. to the original one you just built? Is it assumed to be tangent? Does it have additional information about whether or not it's tangent? Is just a reverse curve where you have to change the radius information from a positive to a negative or a negative to a positive, and also the cusp of the curve. Now supports elliptical curves. Are these ever used in parcel boundaries? Actually, um, it we've got a comment over in the chat window. It's actually not necessarily elliptical curves that are being supported in here, but now there are spiral curves. There are elliptical curves. I don't know of anyone that's got elliptical or Bezier curves inside of any sort of legal definition. However, there are such a thing as spiral curves, and we'll look at them later on as we finish with all of these simple curves in here. Um, good comment though on there. All right. So here's one of those things when I start listing them for people, it's like, well, how many ways can you construct a curve? There's a lot of different ways to build curves in here. There's the standard types of construction tools. These are on the construction toolbar, and it's under the curves. And there is a Bezier curve, and I'm going to construct each of these to show you what they all do on here. There's also a context menu. And if you go in context menu, which is right-clicking, when you're trying to draw something, you right-click and there is a circular curve here, which allows you to define all sorts of elements. This one is very important, especially if you don't know what it's supposed to do or how it's supposed to go. Here's one of my favorites is the fillet curve, creating a curve through doing a fillet of two different lines on here. I'm also going to show you how to do this one. Change segment. This is one a lot of people aren't even aware of. If I go and draw a line, I can convert that line from a curve to a straight line to a curve by using something that's built in to the Edit Vertices tool called Change Segment. And it allows me to go and change to a circular or even to a Bezier curve on here. And I can change them back and forth depending upon what it started out as. Then finally, the one most of us use all the time is a traverse tool. And we'll look at many different ways to input curves in a traverse tool. And then finally, we'll look at the cul-de-sac tool. All right, so we're going to do some demos here. So let's go in here and start doing a curve. Let's do it the simplest way that we can. We're going to use parcel lines in here. We use straight lines in here. So this is the fly off for the curves. And if I start and say, I want to do, let's create a line here. Doesn't have to be any specific COGO line, but I can go and then say, all right, well, I want to go and do a curve that's tangent to my current segment. And I can go and click on this. And as soon as I do that, I start seeing a curve. That curve now has a radius point coming out tangent or 90 degrees to the line that I've already drawn. And the question I often get is, well, how can I control where that's supposed to be? Right now, I can type R on here and I can input a radius. The downside to this is that you can't tell it how long it's supposed to be, just what that is, what that radius is. And let's just say 200 feet. All right, I can now hit enter, and now that's my radius. Um, this is primarily used for connecting lines together on here, making sure you're tangent to here and such. I tend to not use this very often. There's better ways for me to go and build a curve than that. The next one is this is endpoint arc segment. This one I use all the time. So if I want to go and create a curve, matter of fact, I'll use it later as part of my demos of the tessellated curves. If I want to go and create a curve, now let's go put another line in here. And I want to put a curve, and I want that curve to be 2-point curve. Excuse me, the endpoint curve. What I do is I start it at one point and I tell it to end at the next point, and then I can draw what my radius is, or if I know what my radius is supposed to do, I can again use that shortcut key and use an R in here and tell it what my radius is supposed to be. 20 feet in there. Um, yeah, let's do it. 50-foot radius on here. Now note one of the things, if I use Cocoa lines, it will actually store that value in there. And if you look right now, it's a magenta color. It's not black like we usually see. That merely means that while I have a value stored in my radius field, I have 50 feet in there. I've got nothing as far as my orientation being stored. I've got nothing else in here to signify that this is complete as far as Kogo. A magenta label on ArcGIS Pro Kogo means that it's an incomplete Kogo value, and there's other things that are missing on there. All right, so that is an endpoint curve. Again, this one I use an awful lot when I'm doing things. Let's get off of that. All right, let's go to the next one, which is this one here, which is your arc segment. And again, endpoint. And then this is where the middle point is a point on the curve in here. All right. Again, I can still use R for my radius on here, but this one again tends to be because I tend to build the structural lines coming in and then building the curve on there. Not as useful on here for someone who's doing cadastral mapping, but it's still useful for somebody else. This is where you want a curve to go through a specific point, and then you want to define the rest of your curve. That's the that is the arc segment curve on here. All right, so let's go back here. Those are the normal constructions. While we're at it, let's go ahead and do a Bezier curve. All right, a Bezier curve allows me to create elements on here that define it. And again, these elements are not parameter based. They have nothing to do with what we normally would define of a simple curve. So again, parcel mappers and cadastral mappers don't really use these curves at all. It's a graphic curve more than anything else. All right, let's look back here. Context menu. All right. This one with the context menu, if I start on a line, what the context menu will do is when I right click and say circular curve, is that context menu will automatically calculate what that line is that I started on and use that as the tangent bearing for that. Now, note on here, I have the ability to set what my azimuth is, whether it's north azimuth, south azimuth, polar, or quadrant bearing. It will use whatever I have. And then I can put two different parameters in here. I could put, for example, maybe this is a 70-foot radius and my arc length is 150 feet. As soon as I start doing that, it still starts showing me a preview of what this is supposed to be. I can change it and say it's supposed to go to the right instead of to the left. I can go and change it and say, well, maybe it's only 75 feet. Or, and this is the very important thing, is I can change, for example, and say that this is the parameters that I'm given are the orientation, and then I'm giving a chord length of maybe 50 feet, and I'm given an arc length of of 65 feet in here, and it's to the left or to the right. So when I'm using this context menu for the circular arc, I don't need the radius. I can go and input it without having the radius. And the Traverse and most of the others, I need to know what the radius is. On the circular arc tool, and this replaces the arc map curve calculator tool. Curve calculator, you used to go put this in, it would tell you what the other parameters were. This doesn't do that. This just says, okay, if you're going to do something, tell me what you know. And I'll try to go and give you an illustration of what this should be. This is a very important tool, something you should put in your back pocket. You're going to use this a lot in many different ways. All right. And once you hit enter, that curve becomes fully populated again. You then have the chord distance in here. You have the radius, the arc length on there. All right. So it's again something that's very important in here. The fillet tool. This is sort of old school mapping, and that what we used to do is we used to have these two lines in here, and we have to go and put a curve cut or some sort of a curve in between those. And there is a tool called fillet. And what the fillet tool allows us to do is it allows us to go and say, I want this line and this line, and then it will give you all of the different possible solutions in all four quadrants of the intersection of those lines. Now, what this will also do is this will also trim everything up. And this is a really nice tool. The problem is this is uncontrolled at the moment. However, there is a fixed radius here in which you can tell it that this radius is supposed to be 25 feet. I can now go in here and it will have 25-foot radiuses on each of these. So I don't even have to have those matching or intersected already. As soon as I hit 25 feet and click on it, it automatically will go and trim the other lines up, extend them to where it fits, puts that 25 foot in there. Note on this that I have one of my lines. This is the one that I actually input and entered COGO values on. So I have the radius of being 25 feet. My arc length is 33. It does not have my direction on here, but it has the information that I put in here and told it to go and do that as part of that fillet tool. This one again, this is old school. Um, we used to do this a lot when we would have like streets and we'd have streets coming in and sorry, I don't want to do that. We would have street center lines that we would create by paralleling off of, and then we would go and do a fillet and say that our curve cut maybe was a 15-foot radius, and we would go here to here, there, here to here, here. Again, trims, goes and fills everything up, puts the curve in there. It's a really nice tool. These are all tangent curves to the lines that we're telling it to go and intersect. This is a really nice tool, especially if you're doing subdivisions on here and you've got one consistent curve throughout there. It's nice that you've got the fixed radius point up or the radius distance up there. You can automatically go and fill that in and just go around and fix all the rights of way on there. And from there, you go and split them up into lots and such. Again, another one of those tools, if you're building it more from a old school skeletal subdivision on here. This next one is very, very interesting. This change segment. And again, this is one that's been hidden. It actually was an arc map at one time. Um, so if I draw a line, all right, draw a line on there. Again, I don't have to do anything else on there, but that tool is not actually available until I go here, go to edit vertices. Once I go to edit vertices, and by the way, it's not here either. I actually have to go onto that tool, right click and say, change my segment to an arc, to a curve. Now I can tell it what radius I want that curve to be. Maybe I want to do a 50-foot radius and then change it. The value is too small for here. Okay, so it's more than 100. So let's go and change that to a 60-foot radius on there. Go and try this one more time. It won't let me do that. It's already changed it now. When I click on here, it'll automatically go and change it to there. So that segment is one which is very helpful in that let's say that we are doing a curve and we're not quite sure how it's supposed to go. However, what we are receiving, what we have on our legal description is a chord length and a chord distance on here. So we can go in there and create our line coming into the curve and then put the curve, or excuse me, the chord bearing and distance in there, and then the line coming out of the curve on there also. And then what we can do is you can select this line and say, select that. And then we can say, again, here, go and say, change this to a curve, tell what the radius is supposed to be of, I'm not having any good luck there, but yeah. And then tell it plus. All right. So it will allow us to go and input the traverse to that area, um, even if we don't know what that radius is at the moment. So it's another way to go and solve some of those that don't necessarily give us everything we need. If I'm ranking some of the ways that I do it, I tend to go and use the traverse to go and input what values I do have and I'm confident of. And then I'll go back and I'll go and use, while I've got that and I don't know all the curve parameters, I'll jump over and I'm going to go and demonstrate that next. Let's go back here to the traverse tool and how you can take the context menu and use it in conjunction with the traverse. Let's go ahead and do some cleanup first. All right, let's get rid of this, get rid of this. All right, I can. All right, let's go and start again. 45 degrees northeast for 100 feet. Our next line, our next curve is 90 degrees northeast, 0 for the distance, 50-foot radius. And let's put a, I think I said 45 degrees D for the delta angle. All right. So my, I forgot to put central chord bearing there. Sorry about that. My 35 degrees D for my delta angle. There you go. So there it is there. By the way, all of the actual parameters to what you put in here is stored and available down here on a help file. That's the only place that that link appears. And that brings up the entering the traverse tool. Go down to the very bottom here, close to the bottom, and you'll see shortcuts, data entry shortcuts. And this will give you shortcuts for everything from quadrant bearing to closure, angle shortcuts, as far as deflection and interior angle shortcuts, calculator shortcuts. You can now add and subtract and divide the distances in the grid. Curve overruns. This is the one for putting curves. TB for tangent bearing. Radial bearing is RB. Chord bearing, CB. As you saw in my last mess up right there, you have to add these in order for it to understand you're supposed to do a curve. And then chord length here, delta angle, D, arc length. By the way, delta angle is the same as the central angle. Arc length is an A on here. All right. Um, again, The overrides, while you have default ones set up on the top, you can input anything along the way on there. There's also distance overrides in here as far as using a different unit on here. So that's very helpful. You might want to go and think about exporting that out just to let you know. All right. So now with the traverse grid, what it does is it gives you the ability to go and see what the tangent angle is coming out of that curve, and it automatically goes and gives that. This is a great safety tool, and it's a double check. You want to go and use that all the time. Let's go and do a broke back one here. Let's just assume that in fact, we're now going 45 degrees southeast for 100 feet again. Oh, sorry, I didn't move forward on there. Let's go and input. Let's go and delete this. Let's go and input one before here. This has the 45 degrees, excuse me, 90 degrees. It's a chord bearing, 0, 50. I think we did 45 degrees delta angle. All right. Again, so much in here you can go and hide and such. So now I should be here, here. This should be my next point on here. I can go and get to this final point that I was at before, and which was, all right, what happens if I want to use that context menu to input something from here? I can actually click on my construction tool here and say, all right, now let me draw instead. And I can say, I'm going to do a circular curve here. And it will use the bearing coming into my curve, south 45 degrees east. On here is my quadrant bearing. I can now tell it what my radius is. I can tell it what other parameter I might have on here. Let's do a delta angle of 45 degrees. Let's make sure that when you're doing this, if you've got minutes and seconds, whether you're going to have degrees, minutes, and seconds, or whether you're just going to have decimal degrees, make sure you set that. Be careful with that. And then whether it's to the right or to the left, this is the negative or the positive radius. With this, the context menu, you don't have to worry about it. It's going to show you exactly what it's going to be anyway. And then when I hit positive, what will happen on here, actually it's negative, it's enter this. What will happen is it actually goes and takes the values that I drew. Thanks, I clicked on there again. Takes that value that I drew and move it over onto the grid. All right, so you can draw here and pick up from here as you're going along. So that's the traverse tool. The traverse tool, again, is used very, very useful when you use it in conjunction with the context menu and create a curve in the middle of a traverse. It'll go and bring it over and put it into the traverse tool for you. Very, very helpful. All right, a couple more things. Let's go to cul-de-sac tool real quickly. This is another way to go and input the actual values in here. All right, let's go and draw a center line. This could be a street center line. The tool is actually located in your Kogo area. It's called the cul-de-sac tool. Cul-de-sac tool brings up a pane, and I can use a template or I can use the same one that I'm working on now. And I can tell it where to put the curve, the cul-de-sac at the end of it or at the beginning of it. I'm going to set this just as a parameter. All right. And then what's the overall street width? This width is the total width. This tool assumes that the line that you have is a center line. It's not an offset line at all. So let's say that this is a 50-foot right away, excuse me, a 50-foot right away. The radius for the large cul-de-sac area is 60 feet, and my returns are 15 degrees or 15 feet each. When I do this, it will create a line. It will create a series of lines that using this template at the end of this line, and I can go and flip this at the end of this line using a 50-foot wide right of way. That's total right of way. That's 25 and 25 and 60-foot radius for the total here and a 15-foot radius for the returns on here. And I can say create this and it will go and create it for me. This works whether this line that I use is a single line, whether it is a curved line. It also work if I have, for example, let's go and create an offset line. Use that for my cul-de-sac. And you can see it will go to what would be the overall the parallel lines to that. 25 feet and 25 feet from that. Here, let's see if I increase this to 100. It would go all the way around to there. Nice tool. Helps you if you're building things from scratch as we used to with old school ArcMap. Cul-de-sac. On this, again, there's a lot of tools in here, a lot of different ways that you can build curves. Take whatever values you have in your legal description and input them as much as you can, and then make sure that your curve is constructed from that afterwards. Know that it's not just the simple traverse that you can use, but you can use the context menu in conjunction with it. You can use a fillet tool. You can use these construction tools in conjunction and just make sure that you input the curve all the way. All right. Again, many times, many of these elements are just implied by common usage and not commonly provided. You know, no orientation is provided. It's assumed to be a tangent curve, a simple tangent curve. You've got a curve here where we've got a radius, a delta angle, and an arc length. Maybe the previous course for the orientation was this. Well, how would I build that? I would go and use this as my tangent. This is my radius. This is my central angle on here. And the only thing I don't know is whether or not this is to the left or the right. I don't know what the orientation is on here, and I can build that out as I go. So give us something a little bit weirder. Spirals. Spirals are often used with railroads. And the reason, and also it's used for interstate access and off ramps and things like that. What it does is it allows you to go and enter into a curve because of the velocity and the speed at which you're moving, it has it so that it doesn't necessarily go and cause there to be a major problem. It's either increasing radius or decreasing radius as you go along. All right, and if you look here, this is traditionally how this will happen. There will be a tangent coming in, and there will be a short entrance curve, all right? An entrance curve, which will have a central angle on it, a beginning radius and an ending radius on here. Then you have a main curve, a simple curve on here. This is used by inputting just the simple curve parameters on here. And then you have an exiting spiral, which goes from this radius down to, in this case, if this is tangent out, infinity. So this is infinity to whatever this radius is for this length. And then this is this radius for these parameters, the arc length or the central angle on here, and then a new spiral here, which goes from here to here from whatever this radius is to infinity on here. So it's a way to go and enter into a curve without having a dramatic decrease in speed or velocity. And if you'll notice when you're driving on an interstate and you get into a cloverleaf interchange, as you're going and exiting or as you're getting on, for the most part, when you're driving, you have to keep changing the radius as you're driving. That's because that's a spiral that's designed by a spiral. Usually, you don't get spirals involved inside of parcel boundaries. Sometimes you do. Sean was good enough to go and give me an example of this here. That this is a plat up in Bonner County, Idaho, and it has specifically a spiral on here. Um, and it says western boundary of here, that's along the east line of here, have a radius here, dental angle of here, and a point of spiral curvature with a record railroad distance of 624 plus 89.5 PCS. The point of curvature spiral. Said curve is a railroad taper curve to the left, which has a center line arc length of 90 and a spiral delta of 1 degree 24 minutes. All right. And by the way, that overall curve is 20 degrees 42 minutes on here. And then it goes and comes out on here to 429 plus here for here to the end. Well, an interesting thing is that this is the legal description as it appeared on the plat. Matter of fact, let me go and show you the plat here. This is actually the plat on here, and it references all of this as being in this curve table here, and it has the arc as being 708.49, a radius of this, a central angle of this, a curve of this, and here. But it really doesn't show anywhere on the survey sketch that this is a spiral other than on that legal description on here. Normally, you would see specifically a spiral component on here. So what I'm going to do is I'm going to try to create this two ways. I'm going to show you a simple curve, and then I'm going to show you the actual spiral tool that's inside of Pro and give you what it's going to provide and what it's going to represent on there. All right. So let's see if I can pull this up and see some of those values in there. Sorry, I've got them over on my screen here. All right. So if I were to go in and start doing this in here, parcel lines, let's just start this here. All right. And it would tell me that on my curve table here, that I've got a chord bearing, 1158.25 southwest, southwest, distance of 0. My radius is 1960.50. 1960.50. And my delta angle is 20 degrees, 42 minutes, 40 seconds. 20, 42, 20 D in here. And there is my curve. And let me go and reset somewhere where I can see this a little bit further. All right. So that is in fact my curve, my pure curve on here. Actually, that's supposed to be to the left, isn't it? Let's change that to a negative on here. And I suspect they've changed this. Um, they've changed it on there. So that's my actual curve on here. All right. However, there's also the ability to go and input on here. If I go in and do this, I actually can input a spiral curve. In this case, let's do my chord as 11.58, 25 southwest. All right. And this is where I have an issue with the legal description and the way it's showing. It gives me stationing along that right of way, but in order to actually figure out exactly where this curve fits in the overall, the spiral fits, I actually have to start building that center line, go through it, figure out what's the spiral portion of it, which is only like 1 degree and such. And then for the other, I'm just going to go and show you sort of what happens in here. And I'm going to go here to a 1960.50, and I'll tell you that the arc length in here was 708.49. All right. So I'm showing you that this is this spiral in here. When you create a spiral inside a Pro, it's creating a graphic using a polyline. It basically is creating segmented on here, but it's one single line. And you tell it how often you want to go and do this, whether it's an angle or whether it's a length of every 100 feet. You wanted to put a vertex on here or a bend in that curve. It allows you to go and build it, but I'm not going to, because of the time constraints, I'm not going to build the whole thing, but I'm going to show you. This allows you to go and build this curve in here, um, or excuse me, this spiral in here. And when I hit enter, I actually have a line there. All right. And I'm going to stop there. That line, actually, if I go and use the vertices and nodes component, it will show me that in fact, there is all of my vertexes on my spiral as I'm going through. So it gives you an approximation of a spiral curve with an ever increasing radius or ever decreasing radius. So you can input curves on here. It also goes, for example, and shows you what the initial radius is and what the end radius is on that segment of the line. So I could use this as an inputting or a starting or entering spiral. I would then do a full simple curve and then do an exiting spiral also, as you can see on this. There's entering spiral and exiting spiral together with the simple curve in the middle. So that's how you can do spirals inside of the parcel fabric. It uses, again, it's one of the new Kogo values inside of Pro. It uses radius and radius 2 being the overall spiral, exiting spiral on there. All right, that's that. Didn't want to spend a whole lot of time. It might be that you encounter this, well, certain counties, certain jurisdictions, you might encounter it more than others. But to be honest, down here in Florida, one time I had to calculate a spiral and that was it. And that was for a railroad taking. All right, so let's move on. We're running out of time here. Let's get down to tessellated curves or densified curves. This is one that a lot of people are interested in. Correcting and using sort of a workflow to calculate this. I'm going to tell you, ESRI will tell you about the um, straight lines and curves tool. I recommend, because this is a batch tool and it's unconstrained because of the algorithm that's using, it often will go and cause things to change. We recommend you don't use that tool. Instead, do it by hand each time because you can define where the curves start, where the curves end on here. It involves two steps. Step one is the setup of that. Step two is the actual procedure. The setup, all right? Be sure to turn on all layers that contain features, including the historic layers, all right? Then you set topology to no topology, and you set up your line features according to the spreadshot, this screenshot, meaning make sure it's set to fix the shape to the curve or to the path. Recently, there's been some changes, and they've slipstreamed that the default value is no longer fit the shapes to the path. The default value is snap the line ends. That's not what you want. You want it to fix the shapes to the path. Then secondly, you want to go and select the endpoint arc on there. Then the process, use the Align Features tool, draw a replacement curve. If you know what the radius is, type R to set that radius. Select the realign points and lines, not the polygons. Delete them, and then run build extent. And then if you need Kogo values to go ahead and do that. So let's go and do that. Let's go and see what we've got here. We've got a densified curve in here. Let's go and make sure in this case all of our lines are turned on. Let's go and run. They're modified. Align features. And let's just use 5 foot. Fix the shape to the path. Go to the endpoint curve. And what we're going to do is we're going to go and start at the point where we see the densified curves coming in here. And we can go here and let's do it to there. And then we can either snap, or if we know the radius, we can type R. Let's assume this is supposed to be 350 feet. All right, what this does is gives us the path. We're now, if we have this set up to say align features without a selection, we can click and say, go ahead and align that part. And it'll go and align it. By the way, I should have made sure I had no topo turned on. No topo is turned on. I then go down here and select the curve and the points in here, unselect the things that I don't want to go and get rid of. In this case, these are the old lines and stuff that haven't been changed. Or here, make sure that I only have selected points and those lines, and I can hit delete. Now, what this will do is this will go and remove all of those on here. And if you've done this correctly and made sure that you have all of your historic and have topology turned off, you will see a straight, a curved line in there. You will not see any segments on there at all. You won't see any points at all. What you then do is go and do build extent. Again, that's a build extent here. I could have gone and done it here, over here, build extent. It will give you a new line. I can go and select that line and say, update the Kogo on here. We'll update the Kogo and give me the new single line with that radius that I defined on here. We can take over here and do this on a set of curves here. All right, again, no topology and align features tool. Use here, here, here. We can say, oh, maybe we start here, go to here. And our radius is supposed to be, looks like it's 25 feet. All right. And it looks like, oh, it looks like it's a curve all the way from there to here. Again, radius. This looks like this is supposed to be 50 feet. All right. I suspect that should have been further around, but we'll use this and say, okay, there it is there. We'll then go and select out. And we'll just select everything that was involved in there. Unselect the polygons and the lines that we don't want to go in and edit. Delete this. We will then go and build extent, take those two lines and update the Kogo on there. All right, and then there's our Kogo values in here with our new lines. Note these lines actually do show that in fact this was created from geometry. If we wanted to say no, 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 we actually corrected it so that they are the actual values. It will then correctly show them. All right, again, one by one, but it's a cleaner and something where you're building heritage data and it's not going to corrupt your data anymore. It's just going to continue to make it better. So again, any questions or comments? It's been pretty quiet in here. If
None in the
not,
chat.
thank you. And thank you all. Go have a great 4th of July holiday. Or if you're in Canada, Heather, I hope you had a great Canada Day yesterday. So have a good one. Take care.